Welcome to another one of my videos. This is the third question on instrumental analysis that I have recorded. This time we're only going to use the proton NMR and the given molecular formula and functional group to identify an unknown. Consider the proton NMR of an unknown compound D, which has a molecular formula of C4H8O2 and is known to have an absorption in its IR spectrum corresponding to a C double bond O absorption. Use this information and the proton NMR data in the data booklet to deduce the structure of D. First, what can we conclude from this spectrum? There are three peaks, indicating that there are three different hydrogen environments in the ratio of 3:2:3. Because the compound has 8 hydrogens in its molecule, that means there are exactly 3 hydrogen atoms having a chemical shift at 3.6 ppm, 2 hydrogen atoms at 2.3 ppm, and 3 hydrogen atoms at 1.1 ppm. Let's now draw all the possible isomers of this molecule. The first isomer would show 4 peaks, as it has 4 different hydrogen environments. The second isomer would also show 4 peaks. The third and the fourth isomers would show 3 peaks. So let's eliminate isomers 1 and 2. Let's take a look at isomer 3 first. We expect to find a peak at 0.9 to 1.1 ppm for this alkyl group. There should be an area of 3 under the peaks, as there are 3 hydrogen atoms having this environment, and a triplet for the splitting, as there are 2 neighboring hydrogen atoms. Remember that the splitting is the number of neighboring hydrogen atoms plus 1. For this second hydrogen environment, we expect to find a more downfield peak, as the hydrogen atoms are more de-shielded or closer to the electron withdrawing carbonyl group, and the area is 2, as there are 2 hydrogen atoms in this environment, and a quartet, as there are 3 neighboring hydrogen atoms. For the third hydrogen environment, we expect to find an even more downfield peak, area of 3, and a singlet, as there are no neighboring hydrogen atoms. Let's check against this spectrum. The peak at 1.1 ppm has an area of 3 and is a triplet. The peak at 2.3 ppm has an area of 2 and is a quartet. The peak at 3.6 ppm has an area of 3 and is a singlet. Everything checks out. Let's confirm that isomer 4 is not the unknown compound. We expect to find the peak at 2.0 to 2.5 ppm for this alkyl group. There should be an area of 3 under the peak, as there are 3 hydrogen atoms in the environment, and a singlet for the splitting, as there are no neighboring hydrogen atoms. For the next hydrogens, there should be a peak at 3.7 to 4.8 ppm with an area of 2 and the quartet splitting. And for the last hydrogens, 0.9 to 1 ppm with an area of 3 and a triplet splitting. So look at these side by side. The peak at 1.1 ppm has an area of 3 and is a triplet, which matches our isomer. However, the peak at 2.3 ppm has an area of 2, not 3, and is a quartet, not a singlet. And 3.6 ppm, area of 3, not 2, and is a singlet, not a quartet. So this isomer cannot be D. And this is how we solve this problem. Thank you for watching. Please like and subscribe.